This is section 7.1, part B, parabolas. Now for this half of the section, they're going to give us information, and then we're going to write an equation about the graph or about the parabola itself, and then we will actually graph the equation that we write. So for this first one, they give us a focus and they give us a vertex. As you notice, the y values are staying the same. It's the x values that are changing. So if we look back at our equations of the standard forms, of the focus, if the y values are staying the same, but the x values are changing, it means this is a graph that's going to open horizontally, and it's going to be in the form of y minus k squared is equal to 4p minus x times x minus h squared. X minus h, no squared. Now your vertex always tells you your h and your k value. So we know h is equal to 1. We know k is equal to -4. On our focus, the focus is equal to h plus p. And we know h plus p is equal to 3, but we do know our h value is 1. So that means p is going to equal 2. So if we substitute in that information, this is going to give me y plus 4 squared is equal to 4 times 2 gives me 8x minus 1. Now to graph this, we do need to find the rest of the information. We already know our focus and our vertex, but we need to find our axis of symmetry and our directrix. We know that the axis of symmetry is going to be y is equal to k, or in this case, y is equal to -4. Our directrix is going to be x is equal to h minus p, or in this case, it'll be -1. So if we graph this information, we're going to go to y is a -4. That is our axis of symmetry. Our directrix is at x equals -1. We know our focus is at 3, -4. Our vertex is at 1, -4. It'll open towards the focus, away from the directrix. In this case, they give us our focus and our directrix. Since our directrix is y equals, then we know that our equation is going to be in the form of x minus h squared. So you'll look to see what information they give you and see which one of the standard forms it matches. We know that our vertex is our h and our k, and we know our directrix is y is equal to k minus p. Since we know our directrix has a value of 1, and we know our k value is 4, to get the p by itself, we are going to subtract 4 from both sides. So -3 is equal to -4, or p is equal to 3. So if we substitute this into our equation, we're going to have x plus 2 squared is equal to 12 times y minus 4. We already know our vertex and our directrix, so we just need to find our focus, which is at h plus p and k, and we need to find our axis of symmetry, which is going to be x is equal to h. Sorry, our focus is at h and k plus p. So if we find our focus, we're going to be at -2 and 7. Our axis of symmetry is just going to be at -2. So if we go to x is equal to -2, we know it's going to be symmetric about that line. We're going to go to our directrix, which is y is equal to 1. Our vertex is at -2, 4. Our focus is at -2, 7. And we know it's going to go towards the focus, away from the directrix. For this example, they give us the focus. They tell us it's opening to the left, and we know it contains the point of 2 and 5. So the first thing we need to do is go back and look at our original standard forms of the equations. We know that it said it's opening to the left, which means it's opening horizontally, so we are looking at this form of the parabola equation. Because it is opening to the left, we do know that our p-value is going to be negative. Now, because we do know that it is opening horizontally, we do know our focus is at the point of h plus p and k, and they give us a point that is on the parabola. So we're going to call that our x and our y. Now, because we already have a p in our equation, we're going to rewrite this so we can get h by itself and replace that h with a p-value. So we know that h plus p is equal to 2. To get the h by itself, we will subtract the p. So h is equal to 2 minus p. Now let's plug in our h value, our k value, our x, and our y. So our y value is 5, because that's the point where it is contained. Our k value is 1. We don't know what p is. That's going to be the variable we're solving for. Our x value that we're given is 2. And we just said that our h value is 2 minus p. Now let's go ahead and do our subtraction here. So this is going to be 4 squared is equal to 4p times 2. We're going to distribute this negative here and here. So it'll be 2 minus 2 plus p. 4 squared is going to give us 16. 2 minus 2 is 0. And 0 plus p is just going to leave us with p. 4p times p is going to leave us with 4p squared. We're going to divide both sides by 4. So we're going to know 4 is equal to p squared. To get the p by itself, we are going to take the square root. But remember, when you take the square root, you need the positive and the negative. So p is either equal to plus or minus 2. But we said earlier, because this is opening to the left, we do know our p-value is negative. So we do know that p is equal to negative 2. If we substitute that back in for our h to find our h value, if p is negative 2, this is going to be 2 minus negative 2, or h is equal to 4. We already knew that our k value is 1. So let's substitute this back in and find our equation. So the equation for our parabola is going to be y minus 1 squared is equal to negative 8 times x minus 4. We already know our focus, but we need to find our vertex, our axis of symmetry, and our directrix, so we'll be able to graph this. Remember, your vertex is just your h and your k, so this will just be at 4 and 1. Our axis of symmetry, because this is opening to the left, is going to be y is equal to k, or our axis of symmetry is just going to be at 1. Our directrix is going to be x is equal to h minus p, or in this case, h minus p will give us 6. So if we graph this information, it's going to be symmetric about the line of y is equal to 1. Our directrix is x is equal to 6. We know our vertex is at 4, 1, and our focus is at 2, 1. When we graph, we go towards the focus, away from the directrix.